So, hi, my name is V. Abhishek Sairam. I am a geography optional student, prepared for civil service examinations. And in this series, I am going to cover basics and concepts of geography. And basics and concepts of geography in the sense, I am going to teach you about interior of the earth, plate tectonic theory, formation of continents and oceans, that means continental drift theory, geomorphic process, that is endogenic and exogenic processes, and how mountains, plains, plateaus are formed, and climatology, oceanography. Okay, so yeah, let us begin with our first class. And initially, I'm going to teach you about latitudes and longitudes. Okay, yeah. Why we use latitudes and longitudes? We all know that Earth is similar to a sphere, is not a sphere, because if we look at closely, Earth is flattened at the poles. There is no such thing called flattening on a sphere. A sphere will be like this. It is bulged at either sides. I mean, all the four. It's not sides actually. On all the four directions per se, it is bulged. But in case of Earth, it's kind of flattened on the poles and bulged at the equator. Okay, so it's not a perfect sphere, not a perfect circle. It's merely a sphere. If something is Earth-like shape, we call it as a geoid. Okay, our Earth is not a sphere; it's a geoid. It looks like a sphere, not a perfect sphere, because it is flattened at the poles and bulged at the center or equator. Okay, now let's get into latitudes and longitudes. Though there are many places on Earth, not though, since there are many places on Earth, it is very difficult for us to locate each and every one of them. Okay, and scientists, or we say geographers, used latitudes and longitudes, or invented latitudes and longitudes as a points of reference. Okay, that means we refer to places using latitudes and longitudes. We refer to places on Earth by using latitudes and longitudes. We refer to them, or we also can say that locate places. If someone asks, where is place X, we say that 86 degrees 30 minutes east. Okay, 86 degrees. If in case of latitudes we use north and south, in case of longitudes we use east and west. Okay, now specifically coming to latitudes. Latitudes are imaginary. That means they are not naturally found on Earth. We just drew latitudes on a map or on a globe to mark certain places or to locate certain places. Okay, they are imaginary in nature. First thing, they are circular. Okay, second thing, and third thing, they are horizontal. Fourth, they are parallel to each other. Fifth, the length of latitudes decreases from equator to pole. Okay, from equator to pole, length of latitude decreases. Okay, yeah. This is the Earth. Please don't mind, it looks like a potato, but yeah, it's an Earth. It is 0 degree latitude. Here it is an imaginary. It is circular. It is horizontal. Okay. It is 0 degree. We call it as equator. Okay. At poles we have North Pole and South Pole, right? At poles we have 90 degree north latitude and 90 degree south latitude. Equator is very important because it divides Earth into two halves. Northern half, that is called as northern hemisphere, and a southern half called as southern hemisphere. Okay. And yeah, there are other latitudes apart from equator, north and south pole. They are Tropic of Cancer in case of, sorry, Tropic of Cancer in case of northern latitude, I mean northern hemisphere, and Tropic of Capricorn, that is 2300 degrees south in case of southern hemisphere. Okay. And above Tropic of Cancer we have Arctic Circle at 6600 degrees north, and Antarctic Circle at 6600 degrees south. Okay. uh, and moreover, we also learned that from equator to pole, length of the latitude reduces. Why? If we observe closely, 0 degree latitude, it has to make it has to travel a longer distance to complete one circle. Okay. As we move from here to here, the distance traveled by a latitude to complete one full circle decreases, if you observe clearly. Okay. So we can say that from equator to poles, length of the latitude decreases. They are parallel in nature, they are horizontal, they are circular. Okay. And similar in case of southern hemisphere also. From 0 to poles, length of the latitude decreases. Apart from locating places, we also use latitudes to determine heat zones on the earth. Let's look into it. Okay. 0, Cancer, Arctic. 0, Tropic of Capricorn, Arctic. Yeah. Heat zones. How do we determine heat zones? Based upon the sunlight. How much a region receives sunlight, we determine heat zones. Okay. These are sun rays. And apart from being a sphere, Earth is also tilted on its own axis. There is a tilt, if you observe. There is a tilt. So, because of this tilt, the sun rays falling on the Tropic of Cancer are 90 degree, or they fall directly, they fall vertically on Tropic of Cancer. Okay. As we move from Tropic of Cancer towards the pole, the sun rays fall slantly, not vertically, they fall slantly. So the net area covered by sun rays decreases from Tropic of Cancer towards the poles. Okay, you understand that? The net area. So if a sun ray falls vertically, uh, the heat concentrated on a certain area increases. It falls on continuously in a vertical manner so that the amount of heat on a particular area increases more. As we move away from tropical region towards poles, the sunrise falls slantly, okay, because of the tilted nature of the earth. As sunrise falls slantly, the net area covered by sunrise decreases. Okay, the net area covered by sunrays decreases, so that the amount of heat absorbed by that area also decreases. Yeah. So from tropical region to pole, the amount of heat absorbed in certain area decreases, or the amount of sunrays falling on a certain area decreases. When compared to equator and 23 or tropical region, that is 23 degrees north or south, sunrise fall vertically on Tropic of Cancer only, not on equator. On equator, sunrise does not fall vertically on an equator except during equinox. Equinox, what is equinox? We learn about in climatology, and at present, you learn that um, sunrise fall vertically on tropical regions, and the vertical nature of sunrise decreases from tropicals to poles, that is sunrise become slant towards poles. Okay, so thus the area between equator and tropicals receive more heat because sunrays fall vertically. Earth is tilted. The tilted part receives vertical rays. One that is away from the tilt receives slant rays. So there is less sun rays on pole regions. Okay, this area receives more sun rays. So more heat. It is called as torrid zone. As we move from equator towards poles, that is mid latitudes, the sunrays fall slantly, so it has moderate temperature. Okay, it is called as temperate zone. And beyond the Arctic Circle, the sunrise does not rise above the horizon. So there would be a complete darkness for 6 months and complete daylight for 6 months, and we will learn about it when once we enter climatology. But beyond the Arctic Circle, sunrise does not rise above horizon. That is, the number of rays falling on that part, that is above 6600 degrees north, is very very less. So this area is called as frigid zone. That is, beyond the Arctic Circle up to poles, we call it as frigid zone. Same in case of southern hemisphere. Yeah. So as far as latitudes are concerned, they are used to locate places on Earth, and also they are also useful for determining heat zones on the Earth. That is torrid zone, temperate zone, and frigid zone. Why there are three types of heat zones on the earth? Because of the tilted nature of the earth. Earth is tilted, so the tilted part receives more sunrays. That is, sunrise falls vertically on tropical region rather than the equatorial region. So the area between equatorial and tropicals receives more sunlight, so it is called as torrid zone. As we move from tropical towards poles, the sunrise falls slantly. The net area that is receiving sunrise decreases, so it is called as temperate zone. Beyond temperate zone, we have frigid zone. Okay, now we'll talk about longitudes. Longitudes, they are vertical, semicircular in nature. Unlike latitudes, they are non-parallel. Okay, distance between uh, each longitude decreases from decreases as we move towards poles. By using longitude, we can name or locate a certain place accurately. If I say there is if I say two places x and y, they both are on 20 degrees north, and y is also on 20 degrees north. Where is x on 20 degrees north? Is it towards east or west? Where is y? Is it towards east or west? So to determine whether a place on a same latitude where it is located, we use longitudes. Okay, on a same latitude there are east and west. To locate a place accurately, we use longitudes. Okay, so for convenience, we took Greenwich longitude as I'm sorry, Greenwich longitude as 0 degree longitude. Okay, Greenwich, the one that passes through British Royal Observatory, is 0 degrees. From here we count the number of longitudes. Okay, uh, towards east and west, they are semicircular nature and are vertical. Similarly, we draw it on east and west. As we move towards poles, the 180 degrees east and west longitude, they come on same line, they intersect at that point. So we can say that from 0 degree towards poles, distance between each longitude decreases. Okay, and they are also useful for determining a place accurately, and they are like the notion of longitudes is east and west, and we denote latitudes as north and south. Okay, if someone says there is a place on 20 degrees north and 30 degrees east, the place would be somewhere here if it is 20 degrees north, and if we draw a 30 degrees east, this is 30 degrees east. Wait a minute, this is 30 degrees east. The place would be somewhere here, 30 degrees east to 20 degrees north. Okay, apart from the please don't forget that they are semicircular in nature. Okay, unlike latitudes, they are semicircular in nature. They are non-parallel in nature because the as you move towards poles, they intersect. If something is intersecting, they are not called as parallels. Okay, and moreover, apart from locating places, longitudes are also used as a reference to determine time. Okay, Earth 0 degree longitude, that is Greenwich. How do we determine time? This is east and this is west. As we all know, Earth rotates from west to east. Why? We learn in primatology. West to east, that is from here to here in anti-clockwise direction. Okay. When sunrise are vertical on 0 degree longitude, that is on Greenwich, we'll call as 12 noon. That is afternoon 12 o'clock. As Earth moves from west to east, okay, by covering the sun, this is Earth moves like this, west to east. Okay, uh, from here to here, if we have to calculate 1 hour from here to here, it will be ahead. Okay, west would be behind. From 0, east would be ahead and west would be behind. Why east would be ahead? as Earth is moving from west to east towards the sun, okay, this would be ahead. It is moving forward. That means from west to east, east part is moving forward, west part is falling behind. So we can say that east is ahead, west is behind. So from 1 hour from 0 degree, that is 12 noon at 0 degree, and 1 hour towards east, it would be 1 p.m. 1 hour on west, it would be 11 a.m. Okay, so we use longitudes to determine places and also to determine time. Yeah, that's all for today. In tomorrow's class, we would learn about interior of Earth, and after that, we're gonna learn about plate tectonics and continental drift. Yeah, thank you.